Today we are going to see combination of errors. The first thing is errors in the sum of two quantities. So suppose there are two quantities A and B, and measured value of A is A plus minus delta A, and B is B plus minus delta B. Now let sum is Z. So Z equal to A plus B. So we can write Z plus minus delta Z equals A plus minus delta A plus B plus minus delta B. Now we write it A plus B plus minus delta A plus delta B. So this is equal to Z plus minus delta A plus delta B. So we can say that delta Z will be equal to delta A plus delta. Now we are going to see the case of difference when there are two quantities A and B. So let's write their difference as Z equal to A minus B, and we write their measured values, and then we write Z plus minus delta Z, which is equal to A plus minus delta A minus B plus minus delta B, or A plus, sorry, A minus B, and then plus minus delta A minus plus delta B, or we can write it delta Z equal to plus minus delta A minus plus delta B. So for error delta Z to be maximum, delta A and delta B must have same sign. Hence, we write delta Z equal to delta A plus delta B. Now, let's see the third case, errors in product. We consider product. Suppose Z equal to A into B. So we write Z plus minus delta Z equal to A plus minus delta A multiplied by B plus minus delta B. Now we open the bracket. So what do we get? AB plus minus delta A into B plus minus delta B into A, then plus minus delta A times delta B. We divide each term by Z, that is AB. So we get 1 plus minus delta Z upon Z equal to AB upon AB, or Z will give AB upon Z. So since Z is AB, so we get 1 here plus minus, this will become delta A upon A plus minus, this will become delta B upon B, plus minus delta A upon A times delta B upon B. Here, this term can be neglected because delta A upon A and delta B upon B both are smaller quantities and their products will also be very small. So, and we can cancel 1, 1. So, we are left with delta Z upon Z equal to delta A upon A plus minus, here also we can write plus minus, delta B upon B. For maximum error, we write delta Z upon Z equal to delta A upon A plus delta B upon B. Now, let's see error in quotient. So for this, we take Z equal to A upon B. Now, Z plus minus delta Z equals A plus minus delta A divided by B plus minus delta B. If we take common A from here, so we are left with A plus minus delta A upon A divided by B 1 plus minus delta B upon B. So we can write it A upon B times 1 plus minus delta A upon A times 1 plus minus delta B upon B power minus 1. We can apply binomial theorem. 1 plus x power n is roughly equal to 1 plus nx. So second term will simplify to 1 plus minus delta A upon A times, this will become 1 minus plus delta B upon. Now, we divide each term by Z, that is A upon B. So we get 1 plus minus delta Z upon Z equal to 1 plus delta A upon A times 1 minus plus delta B upon B. Let's further simplify. So we get 1 plus delta Z upon Z, here write plus minus, equals 1 plus minus delta A upon A minus plus delta B upon B plus minus delta A upon A times delta B upon B. We can neglect this term because it is very small. So we are left with delta Z upon Z equal to plus minus delta A upon A minus plus delta B upon B. For maximum error, delta A and delta B must have same sign. So we write delta Z upon Z equal to delta A upon A plus delta B upon B. Now, let's see error in power of a quantity. So, error in power. So, we write quantity Z equal to A power n, and then error Z plus minus delta Z will be equal to A plus minus delta A times n which is equal to a power n 1 plus minus delta a upon a power n. So we again use binomial theorem. So we get z plus minus delta z equal to a power n 1 plus minus n times delta a upon a. We divide each term by z, that is a power n. So we get 1 plus minus delta z upon z equal to 1 plus minus n times delta a upon a. So delta z upon z equal to n times delta a upon a. And let's see general rule. So z equal to, suppose, a power p into b power q divided by, suppose, c power r. So maximum fractional error in z can be found by writing it as delta z upon z equal to p times delta a upon a plus q times delta b upon b plus r times delta c upon c. So let's see the proof of it. So we can write here, suppose this is equation number 1, we take log of both sides. So log z will be equal to p times log a plus q times log b plus r times log c. And then we differentiate it. So we get dz upon z equal to p times dA upon a plus q times dB upon b plus, but here, sorry, this was in denominator. So here, there should be negative sign. So here, here, okay. So dB upon d minus r dc upon c. Now, above equation can be written in terms of fractional errors. So we write it like in terms of delta. So delta z divided by z equal to plus minus. Here also we can put plus minus p delta a upon a plus minus q delta b upon b minus plus r times delta c upon c. But for maximum permissible error, the signs of each error must be same. So that is, here this minus r delta c upon c will also be written as plus r delta c upon c. So final answer will be, we can write it like delta z upon z equal to p times delta a upon a plus q times delta b upon b plus r times delta c upon c, which is our required result. So we can summarize. In case of addition, we write delta z as sum of the errors into delta a plus delta b. In case of subtraction, we write delta z equal to delta a plus delta b. And in case of product, we write delta Z upon Z equal to delta A upon A plus delta B upon B. In case of quotient, we write delta Z upon Z equal to delta A upon A plus delta B upon B. In case of power, we write delta Z upon Z equal to N delta A upon A, and as a general rule, when Z equal to A power P, B power Q divided by C power R, then we write delta Z upon Z equal to P times delta A upon A plus Q times delta B upon B plus R times delta C upon C. Thank you.